Hello everyone. Today we're going to solve the blending problem. So the blending problem says that we have a major coal supplier which buys products from different coal mines, and it needs to create some kind of blend. And we have some constraints, so the total amount should not be less than 2 million tons. And we have a table that summarizes the requirements and the constraints that we need, and this is the table over here. So let's say for the high ash blend, it shouldn't be less than 40%, and we have many other constraints. The objective is to minimize the price of this blend. The problem you can come back to it and to the slides to get more information about it. What we will care about in this video is how to program using GuruBPy in order to solve this problem. So this is the solution of the problem. We're just going to program this whole thing. As usual, I will start by installing and importing the important libraries that we need for our work, including NumPy and GuruBPy. After installing that using the regular way that we have explained previously, we will first define the model. So we can say model is equal to GuruBPy.model, and I can give it a name. Let's say blend. After that, I will add decision variables. So for here I have 6 decision variables: f, r, m, s, b, l. So I will define these decision variables. I will define one of them, and then I will just copy and paste for the others. Var v type is equal to so the variable type, I'm going to solve this problem twice. The first time I'm going to solve it as continuous, in which the output can be either integer or can be a real number actually. So the output can be a real number. In the other case, I'm going to solve it as an integer program in which the output must be an integer. So the default for this setting is the continuous. Even if you don't define it, it's going to be continuous by default. If you want it to be integer, then you need to define it. So here I will have r, and I will give it a name of r. I'll copy and paste this 6. So I have r, then after r I have m, then s, then b, then l. I'll just rename those things to their corresponding names, m and r. Continue. Oh. Okay, I just misspelled that word. After defining the decision variables, I can go ahead and set the objective. So the objective in this work is to minimize the prices. I have 6 decision variables, and with each one I have their associated price. So the summation of the multiplication of these pairs should be minimized. So I will set the objective model.set objective as 53 times f plus 50 times r plus 58 times m plus 57 times s plus 63 times b plus 54 times l, and I will give it a sense. In this case it is going to be minimized. Yeah, and we're done with the objective function. Now we need to define the constraints. So I will add constraints. So the first constraint is this one. So the summation of R, M, and B divided by the summation of all decision variables should be equal or less, should be less than or equal to 0.4. Constraint, I will add this R plus M plus B should be less than or equal to 0.4 times F plus R plus M plus S plus B plus L. I can then add the other constraint, which is this. So these values multiplied by their corresponding decision variables over the summation of all decision variables should be greater than or equal to 30. So model.add constraint, I have 28 times F plus 31 times R plus 30 times M plus 29 times S plus 30 times B plus 33 times L should be greater than or equal to 30 times the summation of all decision variables. I can just copy them and paste them here. Now I can copy and paste this again. Here it's going to be 18, 21, so on and so forth. So this is going to be 18, 21, 29, 33, 22, 21 should be greater than 26 multiplied by the summation of decision variables. Last thing is to add the amount constraint, which is I will just copy these. So the amount must be greater than or equal to 2 million. 1, 2, 3. Yeah. Now I can solve the problem. Model.optimize. Great. We got the solution, so I can just print the solution out, which is the regular process that we do every time. So for every variable in the model.getVars, I will print the v.var name and its associated value. And these are the outcomes, and as we see, some of the outcomes are not integers, they are real valued. I will now print out the objective function value. And here is the objective function value. In the second case, I'm going to solve this problem using the integer program. I'm going to do exactly the same thing. I will redefine the model, but in this time I will instead of using continuous, I will replace this with integer. So all decision variables now must be integer. Okay. Now everything is the same. I will just copy and paste everything here. The objective function, the constraints, and solving the problem. Printing out the variables, the values of the decision variables, and as we see, all the values are integer. You can just ignore the 0.0. They are all integers. and eventually I will print out the objective function value. As you will see, the difference is somehow slight. So for the linear program we got a better result, but it's very slight better result. It's only this number that is different than this one. Yeah, I believe that. Okay.